Hello, my presentation topic is design of a bidirectional DC-DC converter with high voltage gain for electrical vehicle. So here is the content of my presentation. Motivation, goal of the project, introduction, circuit diagram, result, and with demonstration, conclusion, and references. So motivation, yeah, ensuring the efficiency of electric vehicle in today's world, personal vehicles are becoming more popular to make professionals' life more convenient and time saving. To save the environment and increase the use of renewable energy source, people have been introduced to electric vehicle. To make the electric vehicle convenient and more efficient, researchers are improving various systems of the EV, like charger, converters, regenerative braking system, etc. So the main motive of increasing the use of electric vehicle is decreasing the use of fossil fuel, increase the use of increase the use of renewable energy source. To get a high voltage and make a more efficient converter, the development of is required for um, previous concept of the system, making the system user friendly, uh, uh, to and get a more efficient user. If user get more efficient and convenient vehicle, then they will be motivated to convert the conventional vehicle to electric vehicle. That will reduce the use of fossil fuel and save our environment. Also, people can use the renewable energy source. So the second, then the goal of our project is, the proposed converter represent response will be fast to reach peak value and high voltage gain. The proposed bidirectional buck boost converter will operate in a boost mode in one direction and the buck mode in another direction, with low voltage stress on MOSFET. So, and less switching losses. Synchronized rectification will enhance the efficiency of the converter. So, the I'm introduce the our proposed my proposed circuit bidirectional DC-DC converter we are using in this project. So our converter is has two mode. One is buck mode and another one is boost mode. We use PID controller to control the whole converter, like while to con to process the boosting mode, we increase we actually change the frequency and the pulse using the PID controller. For boost mode, it occur while supplying the voltage from the battery to the load. And here, yeah, for electric vehicle, the load will be always the motor. So our main purpose is boosting the motor to increase its efficiency with using low voltage. And we have the another mode in our circuit converter, that is buck mode. So we make the bidirectional converter so that while some voltage and is generate in braking system, we can use that voltage to charge our battery. So it will also make the our system efficient. Here you can see the circuit diagram of our proposed system, and previously I discussed our total system, and here you can see that one side is step down mode and another side is step up mode. So for step up mode, we will use here the source. I mean, we use the battery for voltage supply, and here we this portion port B is our load side. So while we input the voltage, the buck boost operation will occur, and we get the high voltage in our output and from in port B. And while the vehicle generates some voltage using its braking system, the voltage will go from this side, port V, to port A, and from port A we can store our gaining voltage in the battery. And here is our small prototype. I implement this prototype in our lab. So I did some change, because we always know that the simulated version and the prototype hardware implementation version has needed to some modification to get the result. And also our project has a high motivation to get to serve the electric vehicle. So for that kind of circuit, it is not possible to implement um, uh, in with limited resource. So using some component from my lab, I made this small prototype. So you can see this is our load side, and this part is our the input part. So I actually um, input the voltage from our voltmeter from the supply, and we get the for boost operation we get the voltage here, and for back operation we get the voltage in this side. I will discuss more and show the demonstration of this circuit uh, after a few time. So here is our result, and with demonstration. So at first I implement my circuit in MATLAB to know that is my circuit work properly or not. So for that, this is my circuit analysis. For the boost mode, you can see that this part portion is working, and the for back mode, this portion is working, this switch is turned off. So for so in for this is the for boost mode, and this one is for back mode. And here is our graphical result. This is for the boost mode, I mean this mode, and you can see that our input voltage is increasing according to time in the boost mode. And here is our back operation graphical result analysis, and for after making the regenerative voltage, I mean we give the voltage in our port V mentioned before. By giving voltage in port V, we can see that our circuit work properly, in simulated circuit work properly. The voltage is constantly decreasing according to the time. So here we can see that the buck mode is operated. And here is our demonstration of my prototype, and here I am playing the demonstration video. Here is my bidirectional buck boost converter. Now I am giving the voltage 5 in this input, in the input. Here we can see the voltage is 5. And now the circuit, after changing the duty cycle, it's boosting, and the circuit is now in a boost mode, and it increasing to it's increasing. And here is the duty cycle. And now
after change, and now I am changing the duty cycle for the buck mode, and it's because of capacitor it's decreasing the voltage, and here is the change of duty cycle. And now I am making discharge the capacitor fast because of short timing, so it's become 0 now. Because of input voltage is 2, and input voltage is 5, is backing the system, and it's I'm changing the duty cycle. And yeah, you can see, because of input voltage is 5 volt, but our output voltage is 2 volt.
Yeah,
Here you
2 volt.
can see the input voltage is 5 volt, and the output voltage is near to 1.92 because of bucking the circuit. Here we can find the duty cycle. Here is my bidirectional.
So here is the uh, duty cycle waveform from I collect it from the oscilloscope, and duty cycle is for boost mode. You can see that our duty cycle is around 66, and here is the duty cycle for buck mode, and our duty cycle is 49.6. So the now we are in the conclusion. So the voltage gain of conventional and proposed converter is validated in this circuit, and the proposed converter has fast response according to the previous voltage, and according to the previous model. And the proposed bidirectional DC-DC converter operates in boost mode in one direction. You can see in my previous slide, and buck mode in another direction with low voltage stress on MOSFET and less switches loss. And I use three MOSFET in our circuit. Uh, Synchronization rectification greatly enhance the efficiency of converter. All these advantages made this converter um, more efficient to high power application, mostly in electric vehicle. And here is my references of this project, and I collect most of the data from this paper, IEEE transaction paper. And thank you.